for cutting the clip there on the other one. Let's try to find another point. Something that'll fit on the graph. I think we'll have to use the graphing tool here. So we had this equation, cosine theta equals 4 over r, right? Same thing as what we have for part A. I've just rearranged a bit. So let's try plugging in another r. And think about things that make us be able to solve what cosine theta is. Okay, so like in our special triangles, cosine theta equals square root of 3 over 2. That's one that comes out nicely. Cosine theta equals 1/2. Cosine theta equals square root of 2 over 2. So I think the best bet we have is to plug in 8 for r. Okay. So if we plug in 8 for r, you get 4 over 8, which is 1/2. And then let's see. So 1/2 is cosine theta 1/2. Thinking about special triangles in my head. That means this is a 60-degree angle, but then we're dealing with polar coordinates, so convert 60. So the way I convert from degrees to radians is I just divide the degree by 180 and stick a pi in there. So that's pi over 3 radians. Let me just double check that real quick. Pretty sure it's right, but it is. It's late, so radians. No, that's random. Radians. If I take pi divided by 3, and then I evaluate cosine, 0.5. Okay, got it. So now we have another point to graph. Look, Alex can't fit that one on the graph, so you have to use this button here. And then we wanted 8 for 8 for the radians, and then pi over 3 to be another point. Oh, it won't let us do it. Shoot. Okay, so I got to think of another point. There's nothing pretty. We're gonna have to just use decimal values. That's too bad. Because look, it goes to this 7th. Doesn't go out to the 8th circle, so that's why it wouldn't let us graph it. Man, that's frustrating. There must be a better way of doing it that I'm not seeing, but okay. So wait, we got 8 comma pi over 3. That works, but it just doesn't work for Alex. So let's try plugging in a different value. Let's just try plugging in something that'll work for cosine. Let's plug in just 5. We'll get a decimal value here, okay? So if you plug in 5 for r, and to find out what theta is, we can use our old friend cosine. Inverse cosine is what I should say. So on my calculator, I'm going to do 4 divided by 5 to convert it to a decimal. Then I'm going to hit second cosine. So 0.6435. Man, I don't think they're going to like us using an approximation there either. Can't just type in a number. It's got to be exactly the same number. Oh, I know what I should do. Let's do this in reverse, okay? We've been plugging in values for r. Let's plug in a value for the degrees, okay? So the radians. Let's just plug in pi over 4. Okay, so this becomes cosine pi over 4 equals 4 over r. Or it's probably easier to go back to the original equation. R cosine pi over 4 equals 4. Okay, because if you do cosine pi over 4, that's 180. 1 second. What is that fraction? That's square root of 2 over 2, right? So pi over 4, that's 45 degrees. So that's a square root of 2 over 2 triangle. So if you try to get r by itself, multiply both sides by the reciprocal, by 2 over square root of 2, okay? So that's 8 over square root of 2 which if you want to rationalize the denominator, that's 8 square roots of 2 over 2, which is 4 square roots of 2. Okay, so now we have a point to plug in, okay? We plugged in pi over 4 for the angle, and we got 4 square roots of 2. So let's see if Alex will let us do that. And actually, before I do that, let's hit the... No, we can just use this. We got 4 square roots of 2 when we plugged in pi over 4. That's a point that we want to graph, okay? Oh. Gotta drain the scooter, elf on the shelf. Plot that point, and now we can make a line between those two, okay? Click this point, click another point, there we go. Now we finally got it. Let's just check that to make sure. Okay, so that's it. So for this topic in Alex, it's kind of the best way to do is plug in some points and see what happens, okay? Just takes some getting used to, right? Because r and theta, that's way different than x and y.